All right. The Basics of C Programming by Marshall Brain and Chris Pollette. And I looked up Marshall Brain, and it turns out he's the guy who started How Stuff Works, a website which he then sold for like $90 million or something. Pretty smart guy. And what a name, Marshall Brain. It's like, it seems like a writer's pseudonym or something, because like, marshal your brain and you can become like me, Marshall Brain. Totally smart guy who wrote this excellent review on C. All right, so arrays and variable types. This seems like an odd point in an introduction to a language to start talking about variable types. Usually they put them right at the beginning. But what the heck? There are 3 standard variable types in C: integers, which are basically whole numbers; floating point numbers, which are basically numbers with a decimal; and characters, which are text. Well, the elements of text. An int is a 4-byte integer value. Is it necessary to know that it's 4 bytes? I don't know, but now we know. A float is a 4-byte floating point value. A char is a 1-byte single character like A or 3 without the quotation marks. A string is declared as an array of characters. There are a number of derivative types. Now, what makes these derivative as opposed to those other variable types? I have no idea. A double is an 8-point floating point value. Okay. I'm assuming it's more bytes because doubles are for big numbers. They have a much bigger range. Shorts are 2-byte integers. I guess when a whole int is just excessive and you need to use little things, then use shorts, I guess. Unsigned shorts or unsigned ints are positive integers with no sign bit. No idea what that's about. Operators and operator precedence. Oh, and in the course, that C course that I mentioned in the very first MQL lesson video, he's getting into operator precedence. That is confusing stuff, especially when you see a chart of it and he starts talking about the precedence of brackets and so forth. But I remember precedence in math. It's essentially BEDMAS type stuff, right? So you have the mathematical operators: addition, subtraction, division, multiplication. And we know from math school, elementary school, that you can't just do those operations willy-nilly, because some of them have higher priority, like multiplication and division, have to be done before addition and subtraction. The backslash operator performs integer division if both operands are integers, and performs floating point division otherwise. For example, float a equals 10/3, printf. This code prints out a floating point value since a is declared as type float. Well, let's just copy and do that. What did I do? Extraneous curly brace. Exit status 9. Oh, that is weird. What does that mean? Exit status 9. It's showing me Python type stuff. Yeah, well. As you can see, it generated a floating point number with 1, 2, 3, 6 digits of precision. So all in all, that did what we expected. This code prints out a floating point value since a is declared as type float, but a will be 3.0 because the code performed an integer division. Right. So what if I do that and perform a floating point division? I still get exit status 9, but now it's showing me a much more accurate value of 3 and 3 repeating. Operator precedence in C is also similar to that in most other languages. Division, multiplication occur first, then addition and subtraction. The result of the calculation 5 plus 3 times 4 is 17, not 32, because the multiplication operator has higher precedence than plus in C and in math and life in general. You just got to accept it, even if you're an addition booster. Multiplication is the king, baby. You can use parentheses to change the normal precedence in ordering. 5 plus 3 times 4 is 32, because 5 plus 3 is done first, which is 8. 8 times 4 is 32. 5 plus 3 is evaluated first because it's in parentheses. We'll get into precedence later. It becomes somewhat complicated in C once pointers are introduced. Joy. Programming becoming complicated? What? Typecasting. C allows you to perform. By the way, never mind, I was going to make a bad joke. C allows you to perform type conversions on the fly. You do this especially often when using pointers. Typecasting also occurs during the assignment operation for certain types. For example, in the code above, the integer value is automatically converted to a float. Right? So it was typecast from an integer to a float. Like, if you're on the original Star Trek and you tried to go to a new show, no, it's a bad example. You do typecasting in C by placing the type name in parentheses and putting it in front of the value you want to change. So in the above code, replacing in line 10 equals 10 divided by 3 with a float. Oh, you actually don't even have to do what I did here, where I did the decimal 0.0. You can just type in float in parentheses, and it will magically do it for you. Let's try. Still having exit status 9 warning. Don't know what that means. It's like int. What's int up here? Where is my int? There's no ints here. Maybe it's telling you that it did a typecast, and that's what exit status 9 means. Anyway, you can see that it gave me the 3 with a bunch of 3s at the end. That's a floating point number. Because 10 is converted to a floating point value before the division, thanks to this float. What would you call this? Float directive. Typedef, one of the reserved keywords in C. You declare named user-defined types in C with the typedef statement. The following example shows a type that appears often in C code. So we define some Boolean constants up here, and then typedef integer Boolean. Boolean b equals false, blah, blah, blah. This code allows you to declare Boolean types in C programs. If you don't like the word float for real numbers, you can say typedef float real, and then later say real R1, R2, R3. Oh. Okay, so if you want to define the type in C with a name of your own choosing, then you use that. All right. You can place typedef statements anywhere in a C program as long as they come prior to their first use in the code. All right, so it doesn't have to be at the top with global variables. Huh. I have a feeling that's going to be much more interesting later. Right now, they're sort of skimming along and talking about it. Structures. Yes, using the struct reserved keyword. Structures in C allow you to group variables into a package. Here's an example. Struct rec integer abc float def struct rec r. As shown here, whenever you want to declare structures of the type rec, you have to say struct rec. See, the problem with this is if we don't have an example of how it's used, it's really difficult to understand why this would be useful. Why am I dropping frames, for goodness sakes? I'm not doing anything. Maybe it's time for a reboot. I may have too many tabs open right now. When the type declaration for rec and the variable r are declared in the same statement. You can create a typedef statement for the structure name. So for example, if you didn't like saying struct rec r every time you want to declare a record, what is that? Oh boy, we're starting to get off the path there, buddy. You can say typedef struct rec type, and then declare records of type rec type by saying rec type r. You access fields of structure using a period, for example. r.a equals 5. Huh. I wonder if this is any relationship to Python lists or objects in JavaScript. I don't know. But that's very confusing. That doesn't really tell me a lot. Arrays. You declare arrays by inserting an array size after a normal declaration as shown below. So you put an integer type, an array of integers, name of the array, which is A, and the number of items in the array, which is 10. Or an array of characters named S with 100 cells, essentially. Array of characters, a C string. Floats, 20 floats or 50 records. Yeah, that's got to be like objects. Records in C and objects in JavaScript. That's the analog which I'm aware of. Okay. Different ways to increment. The long way is saying your variable is equal to the variable plus 1. The short way is plus plus, which I think is what gives C++ its name, isn't it? Oh. And then you could do I equals I minus 1 for decrement, or you can just do minus minus. I equals I plus 3, or I plus equals 3. Well, that's fun. Plus equals 3. Same in many languages, I think. I equals I times j, or I times equals j. I think in almost all respects, the short way is superior to the long way. Someone will correct me if I'm not right about that. Try out different pieces of code to investigate typecasting and precedence. Try out int, char, float, and so on. Well, I mean, you got to give me a little more structure than that, because otherwise I'm not really that interested. In a int, still get 0. That's weird. That is weird, weird, weird. Still saying 0. Why? Still 0. It wasn't 0 before, was it? saying A has got to be a float when it's an integer and I try to divide it. Oh, because it has to remain an integer. If you try to divide it and it's not a whole number, it's like, screw you, buddy, here's 0. Investigate typecasting in precedence. Create an array of records and write some code to sort that array on one integer field. Oh my god, guys, come on. This is too big a jump for a newbie. I don't know what you mean by an array of records. Okay, we can use an array. Write some code to sort that array on one integer field. I don't know. I think we may skip that. I think I'm going to skip that. Using the division operator with two integers will often produce an unexpected result, so think about it whenever you use it. Yeah. There you go. Like the unexpected result I got a second ago was 0. Yeah, I think we're going to skip the records exercise. I think we'll just go to the next page. Let's keep going. Talk about functions. All right. Most languages allow you to create functions of some sort, functions that you chop up along program into named sections. I think of them as like paragraphs in a piece of text. Every paragraph is sort of a summary of an idea. A function is sort of like a package of code that does one thing. It outputs something from an input or set of inputs. And these can be reused throughout the program. Functions accept parameters and return a result. C functions can accept an unlimited number of parameters in general. Unlimited, that's a bold claim. In general, C does not care in what order you put your functions in the program so long as the function name is known to the compiler before it's called. We've talked a little bit about functions. May have. The rand function, seen previously, but as simple as a function can get. It accepts no parameters and returns an integer result. Right. So in that program we were working with before, this was the random function. Let's see if I can pull up that exercise that we did before. This one. Yeah, there we go. Dramatic, passionate code warrior. Nope, that's not the one. And that's too old. That can't be it. Oh yes, this is it. All right, there it is. From K&R, which is Kernahan and Ritchie. This is the random seed function using the rand function. Integer rand line declares the function rand to the rest of the program, specifies that rand will accept no parameters because there's nothing in between these parentheses. And it'll return an integer result, which is why it was declared using int. This function has no local variables, but if it needed locals, they would go right below the opening curly brace. C allows you to declare variables after any curly brace. They exist until the program reaches the matching closing curly brace, and then they disappear. How convenient. A function's local variables therefore vanish as soon as the matching curly brace is reached in the function. While they exist, local variables live on the system stack. A stack is still a somewhat abstract concept to me. I'm assuming that if you grew up in the dawn of the computer age when computers filled entire rooms and used punch cards, Stack would make sense because I think it was literally the stack of cards that you were using for your computer programming. I think that's where the word comes from, but I don't know. There's no semicolon after the parenthesis in the first line. If you accidentally put one in, you will get a huge cascade of error messages from the compiler that make no sense. Note that even though there are no parameters, you must use parentheses. They tell the compiler that you are declaring a function rather than simply declaring an integer. Return statement is important to any function. Yeah, I got one right down at the bottom here. That returns a result. It specifies the value that the function will return and causes the function to exit immediately. This means that you can place multiple return statements in the function to give it multiple exit points. If you do not place a return statement in a function, the function returns when it reaches curly brackets and close curly bracket and returns a random value. Many compilers will warn you if you fail to return a specific value. In C, a function can return values of any type: integer, float, char, struct, etc. So vague. There are several correct ways to call the rand function. For example, x equals rand. The variable x is assigned the value returned by rand in this statement. But you must use parentheses in the function call even though no parameter is passed. Otherwise, x is given the memory address of the rand function, which is generally not what you intended. You can also call rand this way. If rand, parentheses, is greater than 100. Or this way, rand. And you notice I did that the other day when I figured out bubble sort. And I called the bubble sort function with parentheses, curly brace, semicolon. In the latter case, the function is called, but the value returned by rand is discarded. Okay. Discarded. That's so cruel. You may never want to do this with rand, but many functions return some kind of error code through the function name, and if you're not concerned with the error code, for example, because you know that an error is impossible, can we ever truly know an error is impossible? You can discard it in this way. Functions can use a void return type if you intend to return nothing. For example, void print header, print program number by Marshall Brain, version 1.0 released, blah, 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 91. Is that when this was first written? 1991? Man, that's going back. That is going back a ways. This function returns no value. You can call it with the following statement: print header. The void print header. You must include parentheses in the call. If you do not, the function is not called, even though it will compile correctly on many systems. C functions can accept parameters of any type. For example, int fact, int I, int jk, j equals 1, 4, k equals 2. There's a loop. J equals j times k, return j. Returns the factorial of I, which is passed in as an integer parameter. Separate multiple parameters with commas. Yeah. All right, well, there's nothing much there that I think we don't understand at a certain level. C has evolved over the years. You will sometimes see functions such as add written in the old style as shown below. Integer add, I and j. Int I, int j, return I plus j. So what are they distinguishing here between this integer add, int I, int j? I don't know, the old style seems more succinct. I think I prefer the old style. I think the old style is better because it uses fewer characters. There's no difference in the way it executes, it's just different notation. Well, then what was the point? What's the point of adding these extra integer declarations here? Seems weird. Weird, man. Is your add ij and I and j. I guess you are adding extra integer declarations here. I don't know. I guess the new way is better. You should use the new style known as ANSI with the type declared as part of the parameter list, unless you know you'll be shipping the code to someone who's accessing only the old style. And of course, this is different for us because we are only doing this as sort of an introduction or a general overview of some of the conventions that will be needed to use MQL. And MQL learning is more direct. It's what we're going to get to once we've done the this little bit.